Hello, this is an overview of NTIRE 2021 Depth-Guided Image Relighting Challenge. We start by reviewing some applications of image relighting. First, image relighting is important for domain adaptation or data normalization. For instance, input images with varying illumination settings can be transformed into one uniform illumination. We can also use image relighting the other way around, for data augmentation, by generating multiple images with different illumination settings out of a single input image. And of course, image relighting remains very important for aesthetic purposes, for example, in photo montage and general photo enhancement. In our workshop challenge, we make use of the novel VDIT dataset. It is made up of 390 Unreal Engine scenes, 1024 by 1024 resolution. Each scene is rendered with 5 different color temperatures and with 8 light source positions. This results in 40 illumination settings and 15,600 rendered images. For this CVPR's workshop, we also released all the associated depth maps for the images in our dataset, and they are now publicly available on GitHub. Previously, we organized relighting challenges in the AIM workshop at ECCV 2020. Precisely, we organized a one-to-one relighting competition, an illumination settings prediction, and any-to-any relighting competition. We noted certain limitations in understanding shadows and geometry. For that reason, we included depth map information in this workshop. And here is the overview of our entire relighting challenges. We had nearly 250 registered participants in our one-to-one and any-to-any competitions. We note that the illumination settings prediction check was omitted in this edition to avoid redundancy because previous solutions already achieved good results. The first competition track is one-to-one relighting challenge. The objective of this track is to transform an image from input illumination settings to the target ones. The training dataset contains 300 scenes, including depth map. Each image has 512 by 512 resolution. There are 45 images used for validation and 45 used for testing. All the results are assessed with PSNR, SSIM, and LPIPS. The final ranking is based on MPS, mean perceptual score, which is the average of SSIM and 1 minus LPIPS. We present on this slide the test results of the final accepted submissions from the participating teams. We show the MPS, SSIM, LPIPS, and PSNR results, as well as the self-reported running times, platforms, and GPUs that were used. The top solution is MPNet. The key ideas used by the authors are to extract depth and image features in 2 separate subnetworks. To extract both structure and texture information, a multi-receptive fields fusion is used, coupled with a novel dynamic filtering technique. This enables an integration of high and low-level features from both networks in a gradual manner. And the authors rely on a UNet-like connections to reconstruct the final output. Other solutions rely on separable albedo or shading predictions, on separate geometry and color encoders with a pyramid-based fusion, or on spatial and frequency domain prediction fusion for obtaining the relate image. The details and remaining solutions can be found in our challenge paper. The second track of the competition is any-to-any relighting. The objective of this track is to transform an image from a known illumination setting to those of a guided illumination setting. The training dataset contains 300 scenes, including depth information. Each image has 512 by 512 resolution. We use 45 pairs of images for validation and another 45 pairs of images for testing. All the results are assessed by Pearson-R, SSIM, and LPIPS, and the final ranking is also based on the MPS. We present here similarly the test results of our any-to-any image relighting track. The top solution is DF-NIRE. The main ideas used by the winning team are to extract depth and image features separately with different subnetworks, to use dilated residual module at every scale to preserve good quality features, to rely on a feature-based illumination estimation network and an illumination-to-feature network. These networks enable a swapping of the disentangled features that makes the any-to-any blind transformation possible. Other solutions include spatial and frequency domain predictions with content and lighting features, or a multi-level encoding with spatial and channel attention. The details of these solutions and remaining ones are all again in our report. To conclude, we will go over some key takeaway messages. With depth maps, all competing teams outperformed the best previous work. There remains large room for improvements, notably in shadow removal and texture regeneration. Relighting has many important applications, some requiring real-time solutions, and we hope these competitions created a cornerstone benchmark to build on. We have made the training and validation dataset as well as the inputs of the test dataset available on this GitHub repository. Some of the codes and papers from the teams are also shared on this GitHub. Thank you to all the participating teams and sponsors, and thank you for your attention.